Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we are discussing chapter wise concepts, previous year question papers and also weekend tests. So there was one test given yesterday, the answers were discussed in the yesterday's video. So today we are starting with another lecture. Today we are continuing whatever we have done till Saturday, that is till dielectrics we have completed, and today a new week, Monday, we are continuing with capacitor and capacitance topic from the chapter Electrostatic Potential and Capacitance chapter. So today we will conclude this chapter. Tomorrow and day after tomorrow, next 2 days, we will do PYQs or previous year questions for chapters electric field and also for the chapter capacitor and capacitance. Okay, so don't miss those two lectures, very important, where entire chapters most important questions will be discussed conceptually, and there you will be understanding what type of question is coming from for KCET exam. Now let's move on. If you have not joined our WhatsApp group yet, I request you to join our WhatsApp group. Here we will be providing the lecture notes, whatever notes lecture that we are giving it here, the same notes will be given to you via WhatsApp channel. Also the weekend KPL will be held via WhatsApp channel. There you will get a question paper every Sunday morning 10 AM. And if you have attended yesterday's question, and if you have attended yesterday's test series, then don't forget to mention that in the comment what was your score. I asked you to do the same in your yesterday's video as well, but today also you can mention what was your score after verifying your answer via the answer solution given yesterday. Now let's start with today's lecture. What all we are going to cover today? First we will discuss about capacitor and capacitance. Without any introduction, we will simply jump to capacitor and capacitance. Then we will start, we will know about parallel plate capacitor, very important. Then we will learn about effect of dielectric on capacitance, very important as well. Combination of capacitors, another important topic, and energy stored in a capacitor, this is also very important. So these 5 topics we are going to discuss today, and let us start with the topic capacitor. Capacitor is a device that is used to store charges. So capacitor is the device that is used to store charges. Meaning of what? So you have suppose you have a purse. What is the use of the purse? You store money inside that, right? Similarly, if I give you a box, you may store coins inside that box, right? So similarly, capacitor is the device which is used to store charges. So you can use that charge for later use. Okay, so capacitor basically the charge money bag. Okay, so money bag or piggy bank for charges. Okay, a capacitor is a system of generally 2 conductors. Okay, so basically 2 conductors, one at potential V1, another at potential V2. Okay, and it is separated by an insulator, generally separated by an insulator. Now remember that if nothing is there, that means air is there. Okay, inside air is there, air capacitor, we call it air capacitor. Air is also an insulator. Even though it is a very weak insulator, it is still an insulator. Okay, so if nothing is there, that means air is present. Okay, air is an insulator. Okay, so generally 2 conducting plates or metallic plates, okay, having some same charges, generally same charges, separated by a distance and having an insulator between them. Okay, usually in practice 2 conductors have charges plus q and minus q, that is equal charges. Okay, usually it is not very necessary. There are some cases where the charges can vary, and also there are single capacitors are available, possible, but single capacitors are not very useful. They have very low capacitance, so we don't use them. We only use double plate capacitor, where we are using 2 plates, may be parallel, may not be parallel, but generally 2 plates. Okay, Usually in practice, the two conductors have charges plus q and minus q, that is they are equal with potential difference. Potential, they are not having same potential. Obviously, one has plus q, so potential is V1, another is minus q, so potential is V2. So potential difference between them, okay, the difference between them, this has a high potential, this is a low potential, so difference is the difference in potential, right? So that is V1 minus V2. Okay, now V2 itself is negative, okay, but when we will calculate it, we will use this, okay, but when we are inserting the values, it will actually add up. We will see that later on. Q is called the charge of the capacitor. This is very important concept, that the charge of an capacitor is any one of them, okay. Charge of the capacitor is any one of the charge of any one of the plates, okay. So this is called the charge of the capacitor. So what is the charge? So capacitor plates are charged to q and plus q and minus q. What is the charge of the capacitor? Charge of the capacitor is this q, okay. Q is the charge of the capacitor, though this in fact the charge of one of the conductors. So basically, even though it is the charge of one of the conductors, okay, magnitude of one of the conductors, still we say charge of the capacitor is q. The total charge, net charge, what is the net charge? Net charge of the capacitor, q net. Net charge is plus q and minus q. So net charge is 0. Now you might say, sir, net charge is 0, then how can we say it is used to store charges? Interesting question. Basically, it is used to store energy. Okay, there are different forms where you store energy. One of the form is via charges. Okay, so this is a device where you store energy via charges. That's why we generally say it is a device used to store charges. Okay, but total charge is 0, and if you, even if you charge one plate, the other plate will automatically becomes negative charge. So that's why there is a mechanism. The mechanism is no longer part of your syllabus, so I am not going to discuss that. But you should remember that it is happening via charges. That's why it is called a device that is used to store charges. Okay, the electric field in the region between the conductors is proportional to the charge q. So the electric field between the conductors, okay, is proportional to the charge q. So if the charge is higher, the electric field will be very high. If the charge is lower, electric field will be weak. Okay, so if field lines will be very densely packed if q is high, field lines will be far away from each other if the q is low. Okay, that is the, if the charge on the capacitor is say doubled, the electric field will also be doubled at every point. So electric field is directly proportional to the charge. So electric field is directly proportional to the charge, and if you double the charge in one of the plates, the other one will also double. So if you double the charge, then electric field will also doubled. You need to remember this, it is not quadrupled. Okay, so if you double the charge, electric field will be only double. Okay, now consequently V is also proportional to Q, and the ratio Q by V is a constant. So potential difference, okay, potential difference between the plate is also dependent on the Q, but the ratio of Q by V is constant. Okay, and this constant is called, the constant value of constant is called the capacitance, or the capability of the capacitor to store charges. How much charge it can store, how much maximum charge, magnitude of maximum charge in one of the plates, how much maximum charge it can keep. That is the capacitance of the capacitor. Okay, so C is independent of Q or V. So this capacitance is independent of Q and V, even though it is the ratio of Q and V. We are saying that it is independent of Q and V. So what is it dependent on? It is dependent on the geometrical configuration, and that is shape, size and separation of the system of the two conductors, and the type of insulating medium between the conductors. So there are two conductors was here, one conductor is here, another conductor here. How the shape of the conductor, okay, and what lies between the conductors, what is the insulating medium between the conductor. Depending on that, the value of capacitance changes, but for a given capacitor, the capacitance is constant. Okay, the SI unit of capacitance is 1 farad. Okay, 1 farad is basically 1 coulomb per volt, or the symbol is 1 C by V. Okay, both are okay, but remember that farad is very high unit, similar to what is coulomb is. Coulomb is also very high unit of charge, because we know that the charge of an electron is 1.6 into 10 to the power minus 19 coulomb, which is very small, right? So commonly what unit of charge we use? We use microcoulomb, we use nanocoulomb. Similarly for capacitance, farad is a very high unit. We usually use nanofarad, okay, microfarad. For capacitance even we use picofarad. Okay, picofarad is also used for capacitance. Okay, pico is 10 to the power of minus 12, right? So pico is also very common for capacitance. From the above equation we can see that large C V is small for a given Q. Now if you see this equation, okay, C is if C is large, okay, C has a very high value, say 1000, okay, and then what is the value of Q? Q is 1000 V, right? Now we can achieve very high amount of charge keeping this value of V very low value, even if suppose V is 1 volt, which is very low, even lesser than your AA battery. AA battery is 1.5 volts, right? So it is suppose that AA battery you are using only single one. So if the capacitance is 1000, you can store 1000 times 1.5. So the potential, you are using a single AA battery, that is 1.5 volt, and still you can store a lot of amount of charge. Suppose this is in nanofarad, sorry, 1000 nanofarad. Without unit does not make any sense. So capacitance say 1000 nanofarad, and still you can store 1500 nanocoulomb charge. Okay, right, just using only 1.5 volt battery you can still store 1500 nanocoulomb charge, which is very high in terms of charge, right? So because the value of C was large, so the meaning of that is, if the C is large, you can store a very high amount of charge for a small v, right? Now if C is high and if you have a very small amount of charge, then the value of V will be less, right? So V and C and Q, they are interrelated, but since C is independent of V and Q, you can control how much charge you want to store by controlling the potential, right? This means that a capacitor with large capacitance can hold a large amount of charge Q at a very small V. That is the meaning of this entire thing. This is of practical importance. In practicality, when you are using capacitor, based on how much charge is required for our operation, we can change the capacitance. If we need a high value capacitor, we will use a high value capacitor. Now capacitor, where it is used, we will see that as well. High potential difference implies that a strong electric field around the conductors. Okay, so if you keep a very high potential difference, okay, the potential difference around the conductor will be very high, right? That means electric field will be very high, because we know that the relationship between electric field and potential is dV by dx. Okay, so whatever is distance, dx is constant, so only thing you can change is dV. So if dV is more, electric field is more. A strong electric field can ionize the surrounding air. Now if the electric field is very strong, what happens? The surrounding air, okay, so this is a negative plate. What it will do, it will attract positive ions around, and this will attract any electrons available around. Okay, so that will ionize the surrounding air. The charges produced due to the ionization are accelerated towards the opposite charge plates. This partly neutralizes the charge on the capacitor. Okay, so if it is an air capacitor, suppose this is an air capacitor, the same thing will happen inside the capacitor as well, right? So inside the capacitor, whatever air is there, suppose nitrogen molecule is there, nitrogen molecule will, one of the nitrogen will lose one electron, okay, and rest of the nitrogen will become positive. So the positively charged nitrogen will move towards the negatively charged plate, and the electrons will move towards the positively charged plate, right. So they will, this way what is happening, if one electron is captured by this positive plate, its charge will reduce, obviously it will reduce by one electron. Similarly this negative charge, it will capture one more positive charge. So it will slowly reduce the charge that you are holding in that capacitor, okay. The charge of the capacitor leaks away due to the reduction in insulating power of the intervening medium. So the intervening medium, if it is air, in case even if it is something else also, it everything has a power, everything has a limit to hold a electric field, okay. So if the capacitance is lower and your electric field is higher, then that means it cannot store too much charge, it is its value will be less, right. Sorry, if the potential is high, if you apply a high potential and if corresponding electric field is high, then it will store less amount of charge. The maximum electric field that a dielectric medium can withstand without breakdown is called the dielectric strength. So what we are using in between, we are using air so far, but instead of air, if we use anything else, for example, if we use a dielectric, also, okay, so between the capacitor plates, if you use a dielectric medium also, it also has a limit, it cannot withstand unlimited amount of electric field, okay. You have to understand that if the electric field is very high, then what will happen, a lot of amount of charge will slowly discharge from electrons will move from negative to positive, and we can say a very high current flows from positive plate to negative plate, okay. Before this breakdown happens, whatever is the limit, that limit is called dielectric strength, okay. Dielectric strength is maximum amount of charge, even if you add one extra electron, it will break, okay. That is the maximum electric field that it can tolerate, right. The dielectric strength of air is about 3 times 10 to the power 6 volt per meter. Don't worry about this value, exact value. If they are giving you some question, they will provide this value. So don't worry about this, but they might ask you if they will give you a problem and they will ask whether it will break or not. That type of question may come, okay. For a separation between the conductors of the order of 1 centimeter or so, this field corresponds to a potential difference of 10 to the power of 4 volt between the conductors. So if you keep this distance to be 1 centimeter, okay, the distance between the conductors, then this dielectric strength is of the order of 10 to the power 4, okay, 3 times 10 to the power of 4. There is a limit to the amount of charge that can be stored on a given capacitor without significant leaking. In practice, a farad is a very big unit. I already told you, farad is a very big unit. So 1 volt, 2 volt voltage will be very big, right. So the most common unit is used in practice are 1 microfarad, 1 nanofarad, 10 to the power of minus 9 farad, 1 picofarad, 10 to the power of minus 12 farad. Okay, these are the some examples that we are using here. So picofarad, nanofarad, etc. different capacitors. The rating is written on that on top of the capacitor. If you find any capacitor at your home, okay, like this, you check the capacitor and tell me the rating. Okay, what is the rating? It will be written microfarad. Okay, and there will be a voltage rating also mentioned in that. So if you find such capacitor, check it and tell me the value. Don't break any circuit. Just if it is available, check and tell me the value. Now if you see, this is one of the example of capacitors where we are using capacitors in our real life. If you know what is this, mention in the comment below. Okay, this is a specific thing that we are using. Okay, you also use, we are obviously me also using this kind of structure somewhere, but you have to mention that in the comment below what is this structure. Okay, and these all circular things are capacitors. Okay, these are all capacitors. There are all different types of capacitors, even smaller capacitors are somewhere there also. Okay, Now you can count the number of capacitors also, but we are not doing it. Okay, so if you know what is this, mention in the comment below. Now let us talk about homework problems that we have given yesterday. Let's solve them one by one. 3-point charges, 3 nanocoulomb, 6 nanocoulomb and 9 nanocoulomb are placed at, this was the homework problem number 1. Okay, so just a break from whatever we are doing. This is a break time. So during the break time we will solve the homework problem. Okay, so 9 nanocoulomb are placed at the corners of an equilateral triangle of side 0.1 meter. The potential energy of the system is. So what is the meaning of that? We have 3-point charges. We have equipotential equilateral triangle. Equilateral triangle means what? What is the basic property of equilateral triangle? A equilateral triangle has all sides equal and all angles equal to 60 degree. Sides, the length we do not know, but angle is 60 degree. Side length, if it is given, it is fine. Now what are all the things given? Things given are charges 3, 6, 9 and distance is 0.1 meter. Okay, 3, 6, 9, all nanocoulomb. Okay, all nanocoulomb. And distance is 0.1 meters, right? Now what they have asked you to find the energy of this system. So what is the energy? How we can calculate the energy? We know that energy is basically, we have already, energy we don't represent in electric field, we do not represent with the electric field is represented by. Energy is given by K Q1 Q2 by R12 plus 3 charges. Remember, we have already done it. K Q2 Q3 divided by R23 plus K Q1 Q3 R13. Right? We have already done that in our previous class. So that question is based on the previous class lecture. So K is common and Q1, R1, R2, R3, everything is same, that is 0.1. So we are taking that as common as well. Okay, remember that because R1, R2, R3, everything, all the distances are same. So we are taking that value as common. Here we can write R12 is equal to R23 is equal to R13 equals to R equals to 0.1 meters. Right. So this is all known. Now what we will do? We will only calculate Q1, Q2, Q1, Q2. Q1, Q2, so 3 times 6, okay, nanometers. So both of them are nanometers, so it will create a confusion. So let me write them. 3 times 10 to the power of minus 9 times 6 times 10 to the power of minus 9. So don't get confused because both of them are nanometers, so there will be 2 10 to the power of 9s. Similarly, we can write, now what we will do? We will not do this way. What we will do? We will take 10 to the power of minus 9 times 10 to the power of minus 9. So what is that? 10 to the power of minus 18. Instead of writing this value for all the charges, we are smart, so we will not do that. We understand that there will be a 10 to the power of minus 18 factor for all the charges. We will write that factor at the end. Right? Smart? Now what we will do? We will only multiply the charges. 3 times 6, 6 times 9 and 9 times 3. Okay. Now multiply and calculate the value. So the energy is given by U equals to, from here we are coming here. Okay. So now K is 9 times 10 to the power of 9 divided by 0.1. We have one more factor here. So let me write that as well. 10 to the power of minus 18 times. What is the value? 3 6 are 18 plus 6 9 are 54. 9 3 are 27. So what is the exact value if you add them? Check the addition and tell me the answer in the comment below. 71, 81, 81, 99. So the answer will be 99. If you have done it before me, then you are genius. Now 9 times 99. 9 times 99 means 1, 8 in hand, 81, 81 plus 8, 81 plus 8 is 89, divided by 0.1 times 10 to the power of minus 9, right? Nano. Now we can write this as 8910 nanojoules, right? 8910 nanojoules. So if you check the answers, I think they have made a mistake. It is not joule, it will be nanojoules. Okay. So there is a typo here. This is 9 nanojoule. So correct answer will be 8910 nanojoules. Now let's move on. Next problem. Polarization of dielectric medium depends on. So what are all the factors that are polarization of dielectric medium depends on? Only on the external electric field, only on the susceptibility of the material, both A and B, none of the above. So we know that polarization is basically susceptibility multiplied by, so polarization is given by epsilon naught for unitless version electric field. So polarization depends on susceptibility as well as electric field. So both A and B is the correct answer. Okay. So now let us consider this parallel plate capacitor where the plate 1 and plate 2 are kept like this. The area of the plate is A. Okay. The surface charge density of this is sigma, surface charge density is minus sigma, and let us take the intervening medium between them is vacuum. Now let us first look into the definition of parallel plate capacitor. Parallel plate capacitor consists of, as the name suggests, two large plane parallel conducting plates, okay, separated by a small distance. So the distance between the plate is very small, but they are separated and also they are parallel to each other. In most of the cases, what they do, it is very difficult to make very large plates, right? You have seen the capacitors images, they are like circulars, but actually they are parallel plate capacitors. Now if you say, sir, I have seen circular capacitors, how can you say they are parallel plate capacitor? What they actually do, they take two papers, paper like materials, okay, and conducting materials, and then they roll it. Okay, I will show the construction maybe sometime in future. So they roll it, okay, and they make that capacitor. If I get a capacitor next time, I will try to dissect it and I will show it to you. Okay. Now the parallel plate capacitor consists of two large parallel plane conducting plates separated by a small distance, and let us now look into the derivation of the expression for capacitance. So in the region 1 and 2, so what are all the regions? Region 1, 2, and that is the intermediate medium. In the region 1 and 2, the electric field is 0. So here there is no electric field. Electric field is 0 here. Electric field only exists in the between the plates. Okay. Now why they are 0? We know that the electric field due to a plate, charge plate, we have done this derivation before. The electric field due to a charge plate is given by sigma by 2 epsilon naught, right? Now because of this charge, suppose we are considering this area, because of this plate the electric field will be sigma by 2 epsilon naught, and because of the negative charge, negative sigma, the electric field will be minus 2 sigma by 2 epsilon naught. So if you add them together, you will get electric field 0. Now in the region between the plates 1 and 2, this is the say region 3. Okay, in this case the electric field is given by, now in this case what is happening? This is acting in this direction, this is also acting in this direction. In the outside, this is acting in this direction and this negative is acting in this direction. So they will cancel each other. Similarly here, this electric field towards an electric field due to this is away. So they will cancel. But inside what is happening? Both of them are same side. This is away from positive charge and this is towards the negative charge. So they will act in the same direction. Whereas if you consider outside, they will act in the opposite direction and they will cancel each other. But inside, they are all acting in the same direction, so they will be added, and the net electric field is sigma by epsilon naught, that is the electric field inside a parallel plate capacitor. Now we know that potential difference is given by E, electric field E times D, right. So we know that the potential difference is given by one more formula that you need to remember, E is delta V by delta L. Okay, I use the differential form, but you can use the normal form as well. Now delta V itself, what we are doing, we are saying this delta V itself is potential difference V, and delta L is the distance D, and that is the electric field E. So from here we can write V is equals to E times D equals to sigma D by epsilon naught. Now sigma is total charge on capacitor plate, so total charge is capital Q, divided by the area is the total charge. So now let us insert the value here as well. So we get V equals to QD divided by A epsilon naught. Now we can continue, V equals to QD by A epsilon naught, or again we know that charge Q is equals to CV. So C equals to Q by V. Now put the values from our previous expression. So we will get capacitor is given by A epsilon naught by D. Now if you see, this is independent of charge Q and potential V. This only depends on the area of the plate and the distance between the plate. Okay, if the intervening medium is vacuum or air, in that case we can write this as epsilon naught. Okay. Now thus capacitance depends only on the geometry of the system. It is independent of potential and voltage. Now effect of dielectric in a capacitance. Now what we are doing, we have inserted a dielectric in the capacitor. Now we want to find the effect of this dielectric. What do we have to do? Let us insert a medium of dielectric constant K. So what is the meaning of dielectric constant? Let us first understand that. So dielectric constant K is basically nothing but the ratio of the permittivity of that medium divided by permittivity of free space. This is the definition of dielectric constant. Okay. So we can see that relative permittivity is basically K times epsilon naught, right. So this is the basic formula. Now what will happen, we know that the formula for capacitance was A epsilon naught by D for free space or for vacuum or for air. Now if I insert a dielectric medium of dielectric constant K, the first thing what will happen is that we have to replace this epsilon naught. Epsilon naught is no longer there, so we have to use okay, my mistake here, it is epsilon, not epsilon r. Epsilon r is same as K. Okay. So we have to use simple epsilon, that is the permittivity of the dielectric medium. So and again we know that A is basically K times epsilon naught by D. So it is K A epsilon naught by D. Now this is nothing but the capacitance when there is vacuum. So vacuum, let us denote this using a symbol, say C naught. Then we can write C equals to K C naught. Okay, this is a very important formula. If you are solving any previous year questions, there are multiple questions came based on this formula where they have asked you to dielectric medium, there is a capacitor, it is removed, what is the charge now? Okay, let us look into the problem. A parallel plate capacitor of capacitance C1 and with a dielectric slab in between the plate is connected to a battery. Okay, when the dielectric slab is removed, okay, keeping the capacitor connected to the battery, the new capacitance and potential differences are C2 and V2 respectively. Then case what is the condition? Okay, so what they have said, they have given you a capacitor of capacitance C1, it has a dielectric medium. Okay, dielectric medium. Okay, dielectric medium capacity is not mentioned though, but it has a dielectric medium. Now next what is happening is, it is also connected to a battery of potential V. Right. Now when the dielectric slab is removed, keeping the capacitor, now you remove the dielectric slab, but the battery is still connected. Now what they are asking, what will be the what is the following condition is correct. Now if you remember that the battery is connected, so the potential difference across the capacitor will remain constant. Okay, potential difference only depends on this battery. So the potential differences will remain constant. So either this option or this option is correct. Now what is happening? Suppose now the capacitance is C naught. That now there is nothing. So vacuum is there. Now we know that capacitance with a dielectric is basically K times C naught. So C1 definitely greater than C naught, right? So which one was the correct answer? Now here they have mentioned this is C naught, not C naught. They have asked this is C2. Okay, so they have given it C2. Now we know that C2 is obviously less than that of the C1. So C1 greater than C2. So correct answer is this. This is a previous year question paper. Now let's look into the combination of capacitors. We will not go into the derivation. We will only do the formulas. Now when there are two different possible combinations. One is series combination. What is that? When one capacitor is connected with another, one after another, this is called series capacitor. Now what is constant in this case? There may be more than one, more than two. Okay, we generally say maybe infinite number of things are connected, right? Theoretically still it is valid. What is constant in this case? The only thing constant is the charge flowing through each of the capacitors. So if Q charge passes through this, so this will be charge plus Q, this will be minus Q. So another plus Q will be induced in this, plus Q minus Q, like this. So total charge flowing through each of the branches will be Q. So Q is constant here, potential is not. Each of them has separate potential. Okay, each of them has separate potential. Okay, so Q here, Q here. Now one more thing I forgot to mention, the symbol of capacitor is this. Generally we use parallel plate capacitor, so generally capacitor is represented using this symbol. If you are still new and if you are not aware of this, then this should be you should know that. And it is not same as the symbol of battery. Symbol of battery or cell, this is symbol of cell. Symbol of cell we are using one big, one small. This is cell, this is capacitor. Okay, battery and all we will learn in the electric current chapter. So for now, just remember this. This is cell, this is capacitor. Now, what is the equivalent capacitance of this circuit? So what is the meaning of equivalent capacitance? Equivalent capacitance means suppose there are 10 capacitors, and sometimes we don't want to use 10 capacitor. We want to use only one capacitor. So what is that one capacitor, the single capacitor, which can be used to replace all the 10 capacitors, or in the reverse, that is more practical in our real life. So you have seen the diagram where 5-6 capacitors are used, because sometimes we will not be able to get exact capacitor that we are required. So we have to use a combination of capacitors to get the exact matching value. That matching value is the equivalent capacitance. So equivalent capacitance is when we replace all the capacitor using a single capacitor, or vice versa. Single capacitor is replaced by multiple capacitors, but still the effect on the circuit remains same. So what is the value of this? So for capacitance C1, C2, C3 connected in series, the equivalent capacitance is given by same as your parallel combination of resistors. So in case of capacitor, it is same as parallel combination of resistor. Okay, so if you remember parallel combination of resistor from 10th class, then you should remember that series connection is basically same. Now also, if only two capacitors, this is a shortcut, often helpful. If only two capacitors are connected, say C1 and C2 in series, okay, then the equivalent capacitance can directly be written as C1 C2 by C1 plus C2. You need to remember this. There are a few more shortcuts we will learn while I have given a specific homework question from your previous year. So if you try to solve that, there will be one more shortcut in that. I will discuss that while discussing that answer in to next lecture. Next topic lecture we'll discuss. Next is parallel combination. Parallel combination is same as resistors where voltage across all the capacitor is same, but charge is different. Okay, charge is different here, but voltage is same. Right. So if C1, C2, C3 are connected in parallel, this is the simplest. C equivalent is C1 plus C2 plus C3. So when the capacitors are connected in parallel, their capacitance you need will be added. When they are connected in parallel, their capacitance is decreased. Okay. This is the simple one, the parallel one, whereas series one is little complicated, opposite to that of resistances. Remember? Now, an electrician requires, this is a KCET problem 2021, a very important problem. An electrician requires a capacitance of 6 microfarad in a circuit across 1.5 kilovolt. So the voltage is given 1.5 times 10 to the power of 3 volts, and the capacitance given is, that is required, the equivalent capacitance is 6 microfarad. Right? A large number of 2 microfarad is available. So what is available? The available capacitance is 2 microfarad. Okay. Capacitance which can be withstand the potential difference not more than 500 volts. So each capacitor can withstand maximum 500 volt. The minimum number of capacitors required for this purpose. Now this is a very simple question. If this restriction was not there, you have to understand that. Okay. So basically if this restriction was not there, then what you have to do, you have to think, okay, 6 divided by 2, that is we need 3 capacitors. Okay, if you look in the options also, the first option is option 3, and I know 90% of you will answer the option 3, but that is option A question, so that is not the correct answer, because the maximum voltage is 500. If you connect them in parallel, each of them are getting 1500 volt. Each of them is getting 1500 volt, and but their limit is 500, they will burn. So you have to understand that optimization, that part, that you cannot use 3 capacitors in parallel, they will burn. So this part is only for that calculation. This part is not essential for anything else, but C equivalent is essential. Now, how you can use multiple capacitors so that you can have a capacitor which can withstand 1500 volt. So this 1.5 times 10 to the power 3 is 1500. This is basically 1500. Now what we will do, we will divide this by the given maximum power limit. Okay, then we will see how many minimum capacitor is required to withstand that voltage. So only 3 capacitor is required, and they will be connected in series. 3 capacitors connected in series, having each of them can withstand 500 volts. So total voltage they can withstand is now 3 times, right? Each of them will have 500, 500, 500. Total voltage is 1500. Now what is the equivalent capacitance? Now that is the trick. So each of them are 2 microfarad, right? 2 microfarad, 2 microfarad. This is series of capacitors. So don't get confused. Okay, sometimes I have seen students get confused between series of resistances and parallel series of capacitors. So don't get confused. Okay, 2 microfarad, 2 microfarad, 2 microfarad. If the equivalent capacitance of one of such lines, say C1, then it will be 1 by 2, 1 by C1 is basically 1 by C1 is equal to 1 by 2 plus 1 by 2 plus 1 by 2, that is 3 by 2, or C1 is equals to 2 by 3. Now this is the one line. Now we need so many lines. Suppose now we need n number of lines. Now all of their capacitance will be added. Okay, all of their capacitance will be added. Now the total capacitance will be 6 microfarad. Total capacitance will be 6 microfarad. Now we can divide. Now we can find N by dividing 6 divided by 2 by 3. Okay, so it will be 6 times 3 divided by 2. So, sorry, 3 times 3. This is still not answer. This is still not answer. We have not arrived the answers yet. N is, we have calculated N is 3 times 3, that is 9. So 9 lines required. 9 lines required. Each line contains how many capacitors? Each line contains 3 capacitors. So now total number of capacitors will be 9 lines times 3 capacitors in each. So total number of capacitor is 27. So you need minimum 27 capacitor to withstand 1500 volt and to work this circuit properly. So this is very interesting problem, even though the calculations are easy, but it is little lengthy. All the calculations are easy. You can solve them without using any calculator, but it is little long. You have to do it carefully and patiently to answer this question. Now, energy stored in a capacitor. As I said previously that capacitor is basically a device which can store energy. Now, what is the expression for energy stored? Now, expression for energy stored derivation is not your PU board syllabus. If you are studying in PU board or in CBSE board, that is no longer there in the syllabus, but the expression is there, derivation is not there. So, energy stored in a capacitor is given by half CV square. So, this is the energy, amount of energy stored in a capacitor. Now, there are different forms of that. We know that Q is equals to CV. So, if we write this expression as half CV times V, then this can also be written as QV. This is another alternative equation, alternative form of this equation. This is only in terms of charge and volt. This is for capacitance and voltage. Now, another equation is, another option is V equals to Q by C. So, if we put that value here, you will get U is equal to half C times Q square by C square, or half Q square by C. These are the three equations. You can remember them. If in question, in exam, generally they will give you one problem where you have, if you use one of these direct formulas, that your problem will be solved easily. Otherwise, you need to convert it into this form, one of the forms, and then use it. All are okay, both are okay, there is no issue. But if you know this one of the forms, it might save some 10 seconds or 20 seconds, which is very important. Okay, otherwise any other problem can be solved using only one formula. This is the most common formula, half CV square. This is easy to remember. Otherwise, if you remember half QV or half Q square by C, that is also sometimes useful for competitive exam only. For another KCET question, in the figure, charge on the capacitor is plotted against the potential difference across the capacitor. The capacitance and energy stored in the capacitor are respectively. So, what is the problem is that charge stored versus voltage is given. Charge stored versus voltage is given, and what they have asked is the energy stored in the capacitor and the capacitance of the capacitor. So, both things you have to calculate. You have to calculate what is the capacitance, and what is the energy stored in the capacitance. These two things you have to calculate. Now, what information is given? Information given is at 10 volt the charge stored is 120 microcoulomb. Now, we know that, first let us calculate the capacitance. We know that capacitance is basically, what is capacitance? Q by V, right? What is the Q? 120 microcoulomb. 120 micro means 10 to the power of minus 6, and voltage is 10 volt. Okay. So, the capacitance is 12 microfarad. So, capacitance is easily calculated. Now, what we have to calculate else? We have to calculate the energy stored. So, energy stored, we know that Now you can use half CV square, you can use half Q square by Q into V, that is also fine, or you can use Q square by C. We have already calculated C. Let me use the simpler formula because these two values are given. Half QV, okay, half QV, Q is 120 times 10 volt. Now this is microjoules. Because this is given in microcoulomb, we can simply write this as microjoules, okay, and we can simplify this as, so what are the options given here? Options given here are, you can see the options, I can simply see the answer now, it is 600 microjoules, okay, 600 microjoules and 12 microfarads, so correct answer is option C. Now, this is the time for homework question. Check the homework question, pause the video if you want, and check the homework question, answer this video, answer this question, and I will be providing these two questions in our next topic lecture, not during our PYQ lectures which is coming up next tomorrow. So we will be covering these two homework problem in our topic lecture, that is when we are starting current electricity chapter. During that lecture, sometime in between the lecture, I will provide the answer for this homework question. Also, I request you to solve all those questions, all these two questions one by yourself without looking into the internet, okay. And if you find there is a figure in this question which is missing, let me draw that figure quickly for you so that you don't get any complaint about it. This is the question. One thing I want to say, that the exact concept required to answer this question is still not done by me, but you may have completed that concept in your class. I am giving you one hint. This concept is related to very important part of current electricity, even though we are dealing with static electricity so far. Potential capacitance, everything is mostly related to static electricity, but this is somewhat related to current electricity. If you are smart and I know you know the concept, so you can answer this question. Otherwise, I am going to solve it anyway. Also, the next question is this one. I will provide each question through the WhatsApp channel, so don't forget to join the WhatsApp channel. I will provide the question paper there, and if you have not yet joined our WhatsApp channel, do join the WhatsApp channel. There is a specific playlist also available in our YouTube channel. You can get and download the videos there. You can check the videos. You can bookmark this channel, this playlist, and you can check whenever I am uploading a video. That is 9 PM every day. Okay. If I am skipping some days videos, I will be informing you in prior that tomorrow there is no video, but tomorrow there will be going to be a video based on previous year question papers. We are going to discuss 2 days back to back. We will discuss previous year question paper for electric field chapter as well as capacitance chapter. Okay. So thank you for staying with me, and if you are seeing this channel for the first time, don't forget to click on the subscribe button, and if you think this video is making your life anything better, then give me a thumbs up. Thank you.